So the role of academia essentially is to push on the frontiers of knowledge. And it does that by deploying some of the traditional mechanisms in terms of research and development, trying out different ideas in lab and seeing whether they work and deliver as expected. Academia, in a sense, is a playground for a lot of new ideas. And also, academia is neutral in a number of senses of the word, in terms of both in terms of openness to ideas, but also commercial kind of directions, which means that academia is very well placed to work with different industry partners and to work with them to realize how some of these ideas could offer modern industrial kind of technologies that essentially then become part of actual road vehicles on the road. So academia has a very important role to play in that sense. Also, there may be other insights and reflections that we have in academic research, which we could then help inform the industry. So not only is it a venue for exploring those ideas coming from industry, as it were, inspired by kind of industry and the market and the consumers, but also push out novel ideas which the industry can then take on board and then adopt for whatever reasons. So one example is cybersecurity. Security is something that is far more mature in traditional IT systems, enterprise IT systems, so the laptops and the computers and the phones that we carry. For modern vehicles, the notion of cybersecurity is still relatively new. And what that means is that some of the processes in terms of development of those security mechanisms, in terms of deploying them, in terms of then maintaining security across the life cycle of the vehicle, there are interesting models, practices that could be learned from other sectors, and academia could play a role in pushing that out. And just to say, this is exactly where I sit. My role is to work with the automotive industry and the associated electronics industry to help enforce a cybersecurity regime going all the way from early ideation, early concept of a vehicle, all the way to when it's on the road, and that in-life operational support is to be delivered for security. The Global Automotive Advisory Council is part of SEMI Europe's body. It's a collection of people within SEMI Europe that represent semiconductor industries, players, and also the automotive industry players who are interested in automotive electronics and the use of semiconductors in automotive. And under GAAC, there are a number of working groups. One of them at the minute is electrification, so looking at this journey towards electric vehicles and making them more optimal. And the other working group, which I lead, is on safety and security. The purpose of the Global Automotive Advisory Council is advisory. Such communities from industry, from academia, from other expert communities typically come together to inform standards or develop new standards, inform and develop new best practices and guidelines for industry to adopt, but also to provide a forum for thought leadership, which is where we can explore new ideas, emerging ideas, and think about what new responses or new methods or new ideas could be adopted to overcome certain challenges or to push on new market opportunities. And so this is exactly what GAAC is doing, and the working groups are the key part of it, because ultimately the GAAC then delivers through a number of these working groups on different emphases that the GAAC adopts. Given the increasing use of electronics and software in modern vehicles, what we see, of course, is vehicles becoming a potential target for cyber attacks. What that essentially means is functions that are there designed to deliver a certain service may be abused for whatever purpose. And the risks could be to do with safety of the vehicle, to do with some operational disruption, some kind of suboptimal state in the vehicle, some disabling of certain feature, privacy risks, because there could be data that is personal data, or there be behavioral elements that could be essentially exposed, and finally any financial risks as well. Now, the challenge, of course, is that vehicles are increasingly connected. They have to be to deliver a number of these services that we talk about, but also they're increasingly complex. They are increasingly carrying this electronics and software in different configurations, coming together to form even more complex ecosystems. So, in a sense, the security of an automotive is becoming quite a substantial challenge. An organization like Siemens, which, given its experience, its breadth, but also its depth, and particularly Siemens EDA, which is where they are positioned with that insight from a number of other industries as well, but also some fundamental core underpinning technologies in terms of system on chip, kind of delivery of low-level monitoring, are very well placed to address this challenge of automotive security. In a sense, we want to be able to have maximum visibility in near real time for us to deploy certain security related controls on vehicles, and that they have to be designed in with technology that is reliable, with technology that is mature, has been proven, demonstrated at least in other sectors, but also with technology that is designed with that very particular purpose in mind, in terms of providing security-related threat detection of a safety critical system. I think the automotive industry is going through a remarkable set of changes in terms of electrification of vehicles, in terms of complexity brought about by electronics and software, but also in terms of new service models where the increasing connectivity to external systems, cloud-based systems, but other technologies as well, in terms of smart road infrastructure and so on, that the OEMs and this industry has to deliver. In a sense, Siemens is very well placed to work with a number of automotive industry players to deliver on this. I feel very confident that with the collaborations that we've had through the work that we've done together with Siemens, but also Siemens' position in itself in industry, both in terms of deep electronics, but also increasingly in automotive as well, is very well placed to deliver on this future that we are all looking ahead to.